Hi there and welcome to this presentation detailing the One Brighton life cycle assessment results. I'm Richard Haynes. I'm one of the co-founders at eTool. Before I detail the life cycle assessment results, I think it's quite important to put this study into context. If we look at the total ecological footprint of humans, there's a number of studies that are similar to this one that I'm detailing here that show that although carbon emissions are quite a big part of the picture, or in particular the burning of fossil fuels, there's a number of other elements to sustainability that actually make up half the pie. So growing crops, grazing, harvesting timber, fishing, and also the physical displacement or the change of land use due to infrastructure, roads, buildings, etc. So if we look at this in more detail and we think, okay, what about the emissions directly associated with buildings? So if we look at the embodied emissions and the operational emissions of building, we can come up with an estimate of around about 18% of the total ecological footprint. You could also argue that there's an element of harvesting timber and obviously land use change that also relates to buildings as well, but it would only be a portion of those pieces of the pie. So I think even if you totally reduce the impact of buildings to zero, we would still effectively be using more of the planet than we require. So there's no silver bullet to sustainability, and this is something that I think underpins the One Planet Living framework, which I'm personally a pretty big fan of. It makes a lot of sense. Although my work's really really focused around zero carbon buildings. As I said, they're not the silver bullet. You need to focus on all these areas in order to get order to achieve true sustainability. So before I actually present the results, I think it's important just to quickly run through the goal, scope and the methodology of the LCA. I'll try and run through this really quickly because it's quite dry, particularly for the non-LCA practitioners in the room. Broadly, the goal was to quantify the emissions, compare those against other options, hopefully improve them for this building and future buildings, and do this in a cost-effective way. So we didn't want this to turn into a PhD thesis, and I think that's one of the advantages of eTool LCA software, is it does allow fast, streamlined lifecycle assessments. The environmental indicators that we've used for this project, we're only focusing on global warming potential, and that's measured in kilograms of CO2 equivalent. So it does include methane emissions, so all global warming gases. There are other indicators that are also calculated by eTool, but they're not detailed in this report. So we do quantify, for example, toxicity, water use, acidification, etc., but they're not detailed in this particular report. If we look at the system boundary, I guess I won't go through this in detail, but it does include all the materials, the transport of those materials, the assembly effort, so the construction equipment and transportation of labour and equipment to and from the construction site, the recurring embodied energy over the life of the building, and also, really importantly, the operational energy. So I think there's a bit of a perception in the construction industry that life cycle assessment's all about materials. Far from the truth. It needs to be the whole life cycle of the building, including operational energy. We also, it's really important to note that, I guess, of the emissions from the system boundary, probably the most important one is for the ICE database. We haven't got data on the recycling and disposal credits of different materials or impacts. Whether it goes to landfill or whether it's recycled and causes an offset, we don't have that transparency with the ICE database, so it is omitted with that version. But some of the other databases that we have already run the study over and will be doing in the future does include that in the system boundary. Again, I won't go into this in detail. It's just the scope of the of what's included in terms of the materials and assembly items, etc., and also the energy energy use items. All this detail is provided in the LCA report. Now, I guess one thing I should discuss is the functional unit. So the functional unit basically enables fair comparisons between different products. So in the case of buildings, we want to ask the question, or we need to ask the question: how can we compare buildings of varying lifespan, size, and amenity? And that's a key question for ensuring that life cycle assessment can be used effectively in the construction industry. And we identified fairly early on at ETOOL how important this was, and we've had a lot of experience in detailing this. So for residential, it really comes down to impacts per occupant per year. So that enables comparisons of buildings with different lifespan and also comparisons of buildings of different size. We produced we actually produced 3 benchmarks. The first one not listed here was just an analysis of existing housing stock in the UK. So this is what we're actually comparing One Brighton against. We also produced a statistical weighted average UK residents for new residents built to the same code compliance that One Brighton was built to. And that was made up of detached, semi-detached, terrace and apartments. And there was a mix of different types of construction systems, etc., to come up with this nominal building. And we also compared One Brighton to an apartment building as well. So we did a separate LCA for a new apartment building, which I guess is business as usual apartment building. So when we look at the global warming potential of those different options, we've got existing housing stock on the left, the UK statistical average in the middle, and UK new apartments, so both those right-hand ones and new buildings. We can see that at least in the design and code compliance, there's an expectation that there's a big reduction in emissions for new buildings. We'll now look at how One Brighton compares to these buildings. I should just mention that although there's a small difference between apartments and average residential, it's not huge. So the next slide you'll see we're comparing One Brighton against that average statistical UK building. Now, over on the left-hand side, we've changed the scale, so it's compressed a fair bit. So a UK average residence, new average residence is responsible for just over 2 tonnes of CO2 per year. The One Brighton as designed, and assuming average fuel mix for UK electricity comes in at around about 1.5 tonnes per person per year. And if we account for the fact that One Brighton is sourcing 100% renewable power, that drops down to significantly lower value. Now, there's a lot of conjecture about how to account for electricity, particularly for green tariffs, and I can't go into the detail on that here. I don't have the time, but there's plenty of detail and discussion on this in the report, and we'll be making some good recommendations about how to solve that issue moving forward. One criticism of life cycle assessment is that we don't have the data yet, so we decided to test that hypothesis by running some sensitivity with different data sources just to see how important the origin of the data was to the results of the assessment. So this is using the ICE database, which is, I guess it's an international database, but it's been collated in the UK and for the UK construction industry. And now we'll compare that to an Australian database, and you may not have even seen a change in the graph. I might just flick backwards there and then flick forward again. So there's a slight change to the results. However, there's certainly no perverse outcomes. The comparisons between those three design options are all very similar, or basically the same. And more interesting than that is what we found when we looked at the reasons for the differences in those results. It didn't actually come down to local manufacturing techniques or transportation of goods. It was more about the methodology of the particular database. So, for example, what happens to timber after its life? Is it landfilled and therefore turned into methane that escapes into the atmosphere, or is it combusted? In which case it has a net positive impact because it's displacing fossil fuels. Similarly, for the allocation of credits for recycled content in concrete, do you give the allocation to the concrete, or if it's blast furnace slag, does that benefit go to the steel manufacturer? So it's more about methodology, those changes in the databases, rather than actual local techniques. For certain materials, there can be big differences in the local manufacturing processes and emissions intensities, etc. But a lot of the time, it's more about methodology. We will be doing more sensitivity analysis or detailing further sensitivity analysis in the report. One of the big ones that we haven't gone into in the presentation will be the future grid energy intensity. So as the UK grid decarbonises, what does that do to the comparisons between the different designs? And we'll also look at more LCI sources as well to further test that hypothesis regarding the accuracy of the materials. We also looked at One Brighton as built. So how did One Brighton perform compared to expectations? So far we've just looked at as designed. Now you can see here, and I really praise Bioregional for their transparency, that there's a significant uplift in emissions. Now if we look at the detail of why there was an uplift, there was a number of changes between as designed and actual. Interestingly, there was a pretty significant decrease in residential electricity use, around about a 30% saving, which is excellent. However, there were some obviously pretty big increases. The first one, and the major one, was the fuel source of the boiler. So the boiler is currently running at around about 29% biomass versus a target of 90%. The aim is to get that to 90%, but I guess there's been some teething problems there. It has run at much higher percentages on certain months, but average over the whole year it's been around about 29% biomass. There's also, and obviously the difference in the global warming potential of biomass versus gas, which is a fossil fuel, is huge, and that's led to a big difference in the as designed versus as built emissions of the building. The next one is the actual demand of energy for heating and hot water, and we're registering about an 85% increase in demand versus expectations. Now there's a couple of potential reasons for this. It could just be the monitoring systems, and they are actually delivering more heat and hot water to the buildings, and so it may actually be a building performance issue, or everybody may have changed out their low flow shower heads with big shower heads and they're using more hot water. But it's indicating at the moment that there's some low system efficiencies, but that's actually Paran's had some discussions with some really experienced mechanical designers, and they are indicating that in reality you're lucky to get more than 50% total system efficiency for distributed heat systems, and the assumptions that are used in the SAP sheets were 85% efficiency for the boiler and 90% efficiency for distribution, which gives you an overall efficiency of 75%. So pretty big difference there, and that seems to be where that change is, but there's further investigations to come in this. There was also some unusually cold weather, which may have led to an increase in demand. We haven't actually been able to quantify that. The stats aren't necessarily supporting the anecdotal evidence there, but we're looking into that further. There was also a big uplift in common area electricity use. It didn't have a huge effect on the overall emissions of the building, but it was certainly a factor. And that'll probably spawn some further investigations as well as what might be causing that. So if we look at target versus as-built versus what will happen if One Brighton actually hit their targets with regards to biomass use in the boiler, then we can see that they'll very nearly hit the as-designed target just by moving to 90% biomass. So even if the boiler efficiency doesn't improve, even if they don't solve the common area electricity overrun, that they'll still nearly hit the target, the as-designed target, which is an excellent effort. I guess in summary, it's just important to relate this performance back to that original UK existing residential LCA. So you can see here that there's a really significant drop in emissions. Even One Bright, with its current performance, which isn't actually running to target as yet, once they hit that target of 90% biomass, you can see where that's going to end up on the far right hand. And I guess 2 points to note from this chart is, one is the massive improvement compared to UK existing residential buildings, and the second point is the percentage of embodied carbon with that final One Brighton building. It's actually a bigger percentage than operational. Now, this will also happen to existing UK residential as the electricity grid decarbonises. However, it's a lot of food for thought about how we consider embodied carbon in buildings. That basically wraps it up for me. I think Edith's up next, and I've gone over time, so apologies for that. Probably inexcusable when you're recording a video, but and I'm not sure if we'll have a phone hookup organised. If so, I'll be available for questions, but otherwise, over to Edith. Thanks.